Alright, let's take a look at the questions I asked you to do. So this is the specimen paper 1. Let's take a look at question 1. So question 1, I hope you know this. Definitely you do. So I'll start off by copying. I need to make x a subject, right, essentially. So I bring the 7 over. Positive 7 bring over becomes minus 7. This simplifies into 18. But it's a negative 8x. So to solve for x, sorry, I have to bring the working over. You just divide by our negative 8, right? Because there's negative 8 times x. Simplify with a calculator, you'll end up with, let's see, negative 18 over 8, negative 9 over 4. Shift SD, and I get negative 2 1/4. Answer. If your answer is a mixed number. Next one, question 4. So you want to expand and simplify this. Okay, let's copy it first. Oops. So how do you expand? Take the first guy, distribute. Second guy, distribute. So first guy distribute, 3x times 2x, 3 times 2 gives me a 6, x times x, x squared. Next one, 3x times 3y, 3 times 3, that's a positive 9, x times y, that's a xy. Next one, negative y times 2x, that's a negative times positive, so it's a negative. 2 times, there's an invisible coefficient 1 over here, so you can think of it as 1 times 2, which is 2. Y times x, I'll just swap them around and write it as xy. Next one is negative 1y times positive 3y. Negative times positive gives you negative. 1 times 3 gives you 3. Y times y gives you y squared. Okay, anything to simplify? Yes, over here you have 9 copies of xy minus 2 copies of xy. That gives you plus 7 copies of xy. Everything else copy down. Right, copy down. But to save some space, I'll just bring it to the left like this. Okay, that's done. So write this down. Okay, good. Next one, question 6. Let's take a look. The expression x squared minus 12x plus 17 can be written in the form of x minus 6 bracket square plus n. Find the value of n. So this is the form of a completed square. Right, whenever you have bracket power 2 and there's a x plus, or it could be in this case minus some number, let's say p plus q, this is the completed square form. So you need to do the procedure for completing the square. Here's how you do it. Start with the expression x squared minus 12x plus 17, put an equal below. You see a x squared, you copy down x. You see a minus, you copy down a minus. You see a 12, you copy down a 12, but divide by 2. Bracket, then put a power 2. Subtract away bracket power 2. What's in between the brackets? It's 12 over 2, or what I like to call half the coefficient of x. Right, and don't forget, this is, you still need to copy down the plus 17. Okay, this x squared minus 12x is equivalent to this completed square version. Roughly, almost completed square version. Okay, you see x, you copy down x. You see minus, copy down minus. You see coefficient, divide by 2. Bracket power 2. Minus away, bracket power 2. But what's in between? The same half coefficient of x. Okay, let me just erase this. Okay, then the rest is just using a calculator to simplify. 12 over 2, that's a 6. If you cannot calculate it, don't worry, you have a calculator. 12 divided by 2. Oh, that's a 6. Okay. And minus, you don't need to worry about the calculation. Just use the calculator to help you. Negative, bracket, fraction, 12 over 2. Close the bracket, power 2, plus 17. Negative 19. Okay. Then now let's compare with the form given in this question, what do you notice? Oh, it's x minus 6 bracket square. Hold on, let me get that. Right, so x minus 6 bracket square plus n is the form they want. Here we also have x minus 6 bracket square, but it's a minus 19. You can think of it as plus bracket negative 19. Alright, you don't have to write it, but the answer will then be negative 19 because here they requested for a plus sign. Here we have a minus sign. You can interpret it as x minus 6 bracket square plus a negative 19. So the answer they are looking for is negative 19. Now explain why when x equal to 6 the expression x squared minus 12x plus 17 has its minimum value. Okay, so first thing you must understand is that any expression x squared is always more than or equals to 0 for real values of x. Sorry, for any real values of x. What does that mean? It means if x is a real number, real numbers are basically positive, 0, or negative, anything. Right? So there are two. What really is x squared? X squared means x multiplied by another x. Then there are only 3 cases that x can be. It's either positive, and since you multiply by itself, so it must also be positive here. Or it could be a negative x, which means both of those x's are negative. Or it could both be 0, so 0 times 0. Okay, in any in the first case, positive times positive gives you a positive, right? If x is positive. The next case, if x is negative, negative times negative gives you positive. In the third case, 0 times 0 gives you 0. So at the end of the day, you realize that x squared is either positive or 0. That's what this notation here means. X squared more than or equal to 0. In this case, x is equal to x minus 6. It's still a real number, right? So that means that I could have just simplified this simply as bracket x minus 6 bracket square is more than or equal to 0 for any real values of x minus 6. But wait, even though you minus 6, it doesn't really matter that it has to be x minus 6, right? In order for this whole thing to be a real number, it also means that the x itself can be any real number. So we can just simplify this down into any real values of x, right? If it can be any possible number, you subtract 6 from it, it doesn't affect it. It's still just some real number. So we can just say, we can just describe any real values of the x itself. We don't have to say x minus 6, although it's also correct. This is just a bit simpler. Okay, good. So now that we know x minus 6 bracket square is more than or equal to 0, that means we know that another way to interpret this is that x minus 6 bracket square has a minimum of value of 0, right? It can't be negative. It starts from 0, or it could be anything bigger than 0. So now, since we know that if you just minus 19 from both sides of an inequality, the inequality direction doesn't change, so 0 now becomes 0 minus 19. Okay, essentially, since I have to write it along a horizontal line, but I would prefer it if it was written from top to bottom. So what I mean is, if you start off with x minus 6 bracket square more than or equal to 0, you can subtract 19 on both sides. Right, the inequality direction stays the same. But wait a minute, what's this expression on the left hand side? It looks very familiar. Oh, it was the answer to part 1 from part A. So it is exactly x squared minus 12x plus 17. You can replace the left hand side. So it's more than or equals to 0 minus 19, which is negative 19. You're bigger than a negative 19. Okay. What does that mean? It means that we have found our minimum value. This guy has minimum value that is exactly negative 19. Right? Bigger than or equals to negative 19 means what? Means you are on the number line. Here's 0. Here's negative 19. Bigger than or equals all the way to the right. So negative 19 is your minimum value. Right? Then, okay. let's see. So since, how would I continue the explanation? I would say, since this expression given equals to x minus 6 bracket square minus 19, which is more than or equals to negative 19, minimum, I'm just gonna write min value of x squared minus 12x plus 17 is equals to negative 19. Okay. Also, if you sub x equals to 6, we get 6 squared minus 12 times 6 plus 17. Let's calculate it. What value do we get? 6 squared minus 12 times 6 plus 17. What a coincidence. It is also negative 19. So there we go. We answered the question. If we substitute x equal to 16, we get negative 19, which is the minimum value. But of course, why is it the same as that minimum value? It's because substituting x equal to 6 into this original expression, the original is equivalent to same as substituting x equal to 6 into the new version, which is the completed square version. And with the new version, I think it's super clear. The moment you substitute x, let me just underline this x, you sub with x equal to 6, what happens here? This whole thing becomes 6 minus 6. Okay, maybe I should color code it. X replaced with a red color 6 minus x bracket square minus 19. You get a 0 square minus 19, which is negative 19. Right? Immediately. Alright, that's how you get the minimum value. Yeah, so that's why when you substitute x equal to 6, you get the minimum value. When x equal to 6, this guy becomes its minimum 0. You subtract away 19, you hit the minimum value of this resulting expression. Okay, next question. Question 8. 2 minus 5 over x equals to x times x plus 2. It can be rewritten in this form: x cubed plus ax squared plus bx plus 5 equals 0. Find the value of a and the value of b. This is basically asking you to expand this whole thing so that you end up with no fractions, right? Over here, there are no fractions. Okay, the coefficients could have fractions, but more importantly, sorry, maybe it should be that the powers of x are integers. Integer powers of x. So here it's a power 3, there's a power 2, there's an invisible power 1, because anything to the power of 1 is just anything itself. Right? And then there's a constant, which is sort of 0. 5 is almost the same as 5x power 0, because anything to the power of 0 equals to 1. Right? 5 is the same as 5 times 1, and the 1 is the same as x power 0. So this is a power 0. 3, 2, 1, 0. 3, 2, 1, 0. Now, except for the case where any is a 0, then 0 power 0 will be undefined, or rather indeterminate, but let's not talk about that. So let's just expand this, right? So and see where we go. If you recall, when you have divide by x, it means that you can have an invisible power, positive 1, and you can bring it up. And when you bring it over, you essentially change the sign. So this 5 over x actually becomes 5x power negative 1. But that's not what we want. We want power 3, power 2, power 1, or power 0, constant. Here there's a negative 1, which is bad. So what can we do? You don't have to worry too much about the negative 1. Just think of it as a x on the denominator. When you have whole number minus a fraction, what do you need to do? Remember, whole number must always have a divide by 1, invisible divide by 1, which makes it into a fraction. Now you have fraction minus a fraction. Make what the same? Make the denominator the same. So you multiply by x at the bottom and the top. Let's see what we get. We end up with 2x over x minus 5 over x. Right? Copy the right hand side. Copy, copy, copy. then combine, so you get 2x minus 5 all over x. If you're faster, you could have just immediately expand this, you get x squared plus 2x. Then what happens next? Oh, here no fractions, integer powers of x. Here we got a fraction, so what do you want to do? Divide by x, bring over. So leave the numerator 2x minus 5 alone, divide by x, bring over becomes a times. But how do we times? What you need to do is to realize that you need to put a pair of brackets around the entire right hand side, then you times the x. Let me color code it. Divide by x in red. After you transfer over, you times x, but there must be a pair of brackets around the entire right hand side. Now let's expand it. So x squared times x, you get x power 3. 2x times x, you get a 2x squared. What a coincidence. It looks almost the same form as what they are requesting for. So copy the left hand side. Let me just bring the working up. Continue over on the right side. So let's see, we need a positive 1x cubed, right? So that means maybe it will be more strategic if we just swap the sides around, because I already see the x cubed is positive and I also see that it's on the left side. 1x cubed, positive 1x cubed is on the left side of the equation, left. And here x cubed is 1x cubed, but it's on the right. So just instead of bringing over and making it into negative x cubed, a more strategic way would be to swap the sides. Okay, then you continue. X cubed plus 2x squared. You bring the 2x minus 5 over. There's an invisible plus sign over here. Positive 2, bring it over, minus 2x. Negative 5 bring over becomes a positive 5, equals 0. Right, because you brought both of them over, you're left with nothing, so put a 0. Okay, then we're done. Now we just have to compare. What we actually need from the question is x cubed plus ax squared plus bx plus 5 equals 0. Do we have that form? Yes, we have that form. So let's just color code it. Purple, light blue, orange, another shade of orange, I don't know. Let's just color code it. Color code. Okay, maybe I shouldn't include. Okay, I need to include the sign. This and purple. Okay, maybe this part I should be a bit more precise. I should highlight the whole thing like this, minus 2x. Okay, so over here, whenever you have minus, just be careful, you have to interpret it as plus a negative 2x, like this, so that it matches the form of a plus bx. So the answer to what is a and what is b, you simply read. So you simply compare the coefficients. So I think you can tell. In this light blue here, we have a ax squared. In the light blue there, we have plus 2x squared. So the answer for a will be plus 2. Positive 2. You don't need to write the plus sign. Whereas if you compare this reddish orange color, plus bx, and this negative 2x, you realize that on the top we need a plus sign, on the bottom we have a minus sign. So what you could do is to perhaps add one more line. You rewrite this as plus negative 2 bracket bracket, then you multiply by x, like this. Then in this case it becomes super clear that b must be equals to negative 2 plus b x plus negative 2 x. So definitely b is negative 2, the middle guy. If it's still not clear, let me highlight it even more precisely. Plus b negative 2 x. So definitely, I think by now you can tell b must be negative 2, not just a 2. Negative 2. Good. It's similar to the previous question about the plus n. There's a plus sign here. They requested for a plus sign over here, but there's a negative. You should rewrite it as a plus something. So maybe I'll color code. Right? Purple is plus sign, light blue is minus 19. The n. Here with that. Okay, moving on. What's the next question I requested for? Let me see. Question 12. This guy, very simple, very standard question. So whenever you have a quadratic like this, don't worry, just type into the calculator and they will calculate it for you. You can eventually factorize it as, let's see, let me get my calculator. For -7, -15, right? So this becomes, if you type this in a calculator, like say treat it as a 4x squared minus 7x minus 15 equals 0, you use a calculator, you end up with x1 equals 3 and x2 equals -5/4. So the trick here is to bring the constant to the left side. Specifically, let's not write the subscript. X equal to 3, you bring it over, you get x minus 3 equals 0. -5/4, you have to deal with the denominator first. Divide by 4, bring over, then you times 4, okay? Times 4, so you get 4x equals -5. Then you have a -5 on the right side. You must always make sure it's a 0. So -5, bring over, you get 4x plus 5 equals 0. Okay, step by step. Times 4, remove the denominator. Get rid of it. Then bring the -5 over, get 4x plus 5. So we got 4x plus 5 here, we got x minus 3 there. That means that instead of a x, we actually should replace them with a y. So we can factorize our numerator as y minus 3, bracket, and 4y plus 5. Notice, here is x, here is x for the equation when everything is in x, but the question actually started with y's, so we have to adapt, contextualize accordingly. Don't just blindly write down the x. Read the question. They represented the numerator in terms, they gave the expression in terms of y, so you must also use the letter variable y instead of x. Okay, all divided by y cubed minus 9y. Any common factors here? Yes, there is a common factor of y. So if you take out 1y from y cubed, you get y squared. If you take out 1y from minus 9y, you end up with minus 9. Oh, okay, then you stop there. Yay, done for the day. Nope, not enough. What you need to realize is that there are 3 key identities you must remember: a plus b bracket square, a minus b bracket square, and a square minus b square. Respectively, they are a squared plus 2ab plus b squared, a squared minus 2ab plus b squared, a plus b times a minus b. Just take note that if it's a minus in the middle, it's a minus in front of the 2ab. If it's a plus here, it's a plus in front of the 2ab. Then, and also there is a coefficient 2 here. Just be careful of that coefficient 2. And for a squared minus b squared, difference of squares, you end up with a product. Okay, so over here, can you see that 9 can actually be rewritten as 3 squared? This requires you to remember your times table. Okay, and a little bit of exponents. 3 squared is 9. Oh, since we know that, maybe I'll just write it as like y squared minus 9 happens to be y squared minus 3 squared. We can factorize it further as a plus b, a minus b. So y plus 3, y minus 3. Is that okay? Good. A is y and b is 3. Then just a plus b, a minus b, right? Okay, then we can simply replace this with y plus 3, y minus 3. Anything common that we can cancel away now? Yes, because now that we have what I call factors. What's a factor? A factor means you're separated by multiplication sign, multiplication sign, multiplication sign. So each of these things I am circling are now factors. In a fraction, you can only cancel off what? Cancel off common factors. Because of the times, then you can cancel off common factors. I think by now you can see it's actually just y minus 3 and y minus 3. They can cancel away. Cancel, and then you're left with an invisible 1 replacing it. You don't need to write the 1. Just know that it's there. 1 multiplied by a 4y plus 5. Of course, you don't need to write the 1 anymore. It's just left with 4y plus 5 over y times y plus 3. Answer. Anything else I should warn you about? Do not cancel off common terms. So like for example, 4x plus I don't know 3y over 2. I see 4 and 2. I cancel away 1 and 2 and conclude that it is equals to 2x plus 3y over 1. Divide by 1, don't need to write. So 2x plus 3y. Is that correct? No. Why? Because you didn't factorize first before you cancel. And also, you can't factorize out a 2 from a 3, so that's not accurate. Even if I change this 3 into something like, say, 6, this is still wrong because you're supposed to factor out a 2 first so that you get a common factor of 2, then you can cancel. Keyword factor. So this is wrong. Let me show you the correct way to do this. If it was 4x plus 6y, 4x plus 6y over 2, what you're supposed to do is factor out a 2 from the numerator. Right, I hope you can tell there's a common factor of 2 between 4 and 6 over 2. Then because this is now 2 times some 2x plus 3, this is sort of like 2 times 1. There's a common factor of 2, so they can cancel away. Right, then you're left with 2x plus 3y. A simpler way to remember this is just factor first, then cancel. Okay, factor first, then cancel. Don't just cancel off a common factor between terms, right? 4x previously was just a term separated by plus signs, right? You can't cancel off terms. You can only cancel off factors with a factor from the numerator and denominator. What's a factor again? When you have multiplication signs. How do you get a factor? You factorize. Factor first, then cancel. Yeah, that's the main point you need to remember for exams. Even if you don't understand what's going on, just remember this factor first, then you cancel. Okay, moving on. Next, question 13. Let's see. So we got, wow, so complicated. Don't worry, it's just the same concept all over again. I'll be a bit lazy and not copy this whole thing down. When you see this guy, what do you call this? Fraction. When you see that guy, what do you call it? Fraction as well. Fraction minus fraction. Make what the same? Make the denominator the same. So over here, what you do is you have 2 and you have 2x plus 3. You just multiply them together. So 2 times 2x plus 3. So what this means is you should take out a pencil or something, some different colored pen, and then you multiply top and bottom by the other guy. Right, remember, do not just multiply simply at the denominator. The top must also be multiplied. Okay, there must also be the 2x plus 3 at the top. Now, for the second fraction, you will also need to multiply by the other guy, which is, in this case, 2. Okay, now, after you multiply, you get this guy minus that guy, and the denominators are the same. So you don't have to write the denominator 2 times, just write it one single time, and the numerator, you just copy down this whole chunk, which is the first guy, minus away, just copy exactly the second guy, okay? Equals 9 over 2. Good. Now we just have to distribute and expand. 1, 2, 3, 4. Right? Let's just do the first pair. 2x times x, get 2x squared. 2x times 1, you get 2x. Erase. 3 times x, 3x. 3 times 1, plus 3. Good. Minus sign over there, minus. X squared times 2, 2x squared. 1 times 2, you get plus 2. Is that correct? Wrong. Why? Because there was a minus sign here. It's better to leave the minus sign alone, expand this first, but a pair of brackets. There will always be an invisible pair of brackets after the minus sign. Okay, then you expand this x squared plus 1 times 2 inside the red color invisible pair of brackets first. Okay, you need to draw the invisible pair of brackets on your own. Okay, then multiply it out. X squared times 2, 2x squared. X squared, positive 1 times 2, plus 2. If it's a bit confusing, you can always swap them around. So 2 on the left and x squared plus 1 on the right, like this. So 2 times x squared, 2 times 1, same thing. So because multiplication, left times right, right times left is the same. 2 times 7, 7 times 2, they're the same. Okay, that's the numerator all over. Copy, copy, copy. Copy, copy, copy. Copy, copy, copy. And done. Okay, so now you just have to open up the red color brackets, multiply it. If you're faster, you can skip this step and give me the correct answer straight away. But if you make a careless mistake, then that's too bad. You didn't follow my instructions. My instruction is to draw in the pair of brackets first, and then you multiply the negative in. Okay, minus go into positive, you get negative 2x. Minus go into positive 2, you get negative 2. Sorry, here, go to there, you end up with a negative 2. Good. Now you start to combine all the like terms. So let me just shrink this down so I can have more space. Okay, let's see. So first fraction, we can see there's a 2x squared there. What else? We see there's the like terms, plus 2, plus 3, minus 2x. Can cancel off the 2x, you're left with just a 3x. Plus 3 minus 2, that's a plus 1. 2 times 2x plus 3, I'll just leave the factor 2 alone, equals 9 over 2. Then I'll just cross multiply now. So let me color code this. The whole thing is yellow, blue, green, purple. Invisible pair of brackets. Then when you cross multiply, you essentially have a crisscross going on. Criss, cross. So the purple goes beside the yellow. Equal sign, no more fraction already. No more fraction already. The 9 on the numerator stays on top. But the light blue goes beside it here, like this. You could put an invisible pair of brackets, it's not wrong. Yeah. Then we proceed to multiply out. Maybe it's easier if I just put the 2 on the left side, because left times right, right times left doesn't matter, right? Like this. So we can multiply the 2 in, you get 4x squared plus, let's see, actually there's a clever trick before that. Let's manipulate the right hand side first. 9 times 2 times 2x plus 3, right, essentially. So this can essentially be rewritten as 9 times 2 times 2x plus 3 in brackets. Oh, there's a common factor of 2 on the left and on the right. Let me just erase the highlighting. I need the bracket, so the 2 on both sides. I can just cancel them off. Yes, exactly. Good. Cancel away those 2's. Maybe I'll use a different color. Right, and as a result, I get what? I get just 2x squared plus 3x plus 1. A lot simpler to cancel off common factors before you multiply. I was about to multiply the 2 in. Wow, it's gonna be very big numbers. I don't like big numbers. Okay, so I'll stick to small numbers. Yeah. Good, so 9 bracket 2x plus 3. Of course, this one you can multiply out. I'm just going to do that. So 9 times 2x plus 3, I get 9 times 2. That's 18x. 9 times 3, I get a positive 27, right? Positive 9 times positive 3 gives you positive. Good, so now when you have power 2, this is what we call quadratic equation. You can use a calculator, but you must first make it into the standard form. Standard form. What is standard form? Right hand side equals 0. Okay, here right hand side clearly is not equals to 0. R for right. 18x plus 3, 18x plus 27, you need to bring it over to the left. So let's do that. Copy the left hand side first. 18x bring over becomes a minus 18x. Positive 27 bring over become minus 27 equals to 0. Combine like terms. So 2x squared here plus 3x minus 18, that's a negative 15x. Plus 1 minus 27 is negative 26 equals to 0. Very good. Now we can just use the calculator. Type it in the calculator. And you end up with x equals to 8.9522. Please write down up to 5SF. Maybe just truncate. Truncate means just copy down 5 non-zeros. The first 5 non-zero digits, right? I know you see 2163, but I'm not gonna bother rounding the 6 up to 2. I'll just write 21. Good enough. It's called truncation. Go look it up. And then after that, you round off to 3SF, 8.95, 3SF. Okay, then next one, or you must connect with or not and. You can't be a negative number and a positive number at the same time. Yeah, 4, 5, 2, 1, right? And then you round off to negative 1.45. Oops. 0.45. Okay, 3SF. That's it. That's the answer. 8.95 or negative 1.45. Good. Okay, what's the next question? Let's see. What was I asking you to do? Question 15, let's go. So question 15, exponents. Let's see how we can deal with it. You see a 9 there? Just leave it alone. Just leave it alone. So we're going to leave the 9 alone. But wait, x power 3, x power 9. Same base, x different power. Same base, different power. Multiply. What do you do? Add the power. So just copy down the x first. Then add the power 3 plus 9. Right? That's it. Okay, so you end up with 9 as a coefficient, multiplied by x to the power of 3 plus 9. I cannot do mental sums. Don't worry, you have a calculator. 3 plus 9, 12. Then you get power 12. Good. Then you just write it down. 9x power 12. Okay, next one. Whoa, this one is difficult. There's a fractional power. Don't worry. First thing is to realize that 16 is a very nice and big number. What do I do when I have big numbers? Prime factorize, exactly. So that means that 16 equals to 2 to the power of 4. Right? How you do it on a calculator? You type in 16 fraction, then you start with the smallest prime number, which is a 2. By the way, 2 is also the only even prime number. All the other prime numbers are odd numbers. It's also the smallest prime number, the starting one. Okay, you divide by 2. Does it give you a whole number? Yes, it gives you 8. So you carry on. You raise this to the power of, that's an invisible 1 already. So raise it now to the power of 2. Does it give you 2 squared is 4, 16 over 4 is 4. Does it give you a whole number here? Yes, then you continue. So now you increase it to a power of 3. And then you check, the answer gives you a 2. Is it a whole number? Yes, it's still a whole number. You continue to increase the power. So now it's a power 4, and you end up with a 1 as the answer. Is it a whole number? Yes, it's a whole number. At this stage, when you get a 1, that means you are done factorizing. Okay? Quick explanation on, let's say, 16 times, let's say 3, it's 30, 18, 48. 48, if you want to prime factorize this, you have to divide by 2. You get a whole number. Just use a calculator to check. Yes, then you proceed to increase the power of 2 from 2 power 1 to 2 power 2. Do you still get a whole number? Yes, you get a whole number. Then you move on. Then you increase the power to a 3. Do you still get a whole number? Type in a calculator. Yes, you still get a whole number. So you move on. Then you raise it to the power of, say, power 4. Then do you still get a whole number? Yes, you still get a whole number. Then you raise it to the power of 5. Do you get a whole number? At this stage, no, you end up with a fraction. Right? 48 over 2 power 5. That's like 48 over 32. You get a fraction that cannot be a whole number anymore. That's when you go back 1 power, type in a calculator, whatever I'm writing in the calculator, put it as power 4, and you go for the next best prime number, next bigger prime number after 2, which is 3. So you times a 3 power 1. And you repeat the procedure. Power 1, is it a whole number? Power 2, divide, is it a whole number? Power 3, divide, is it a whole number? And stop when you reach 1. And you will realize that, immediately when it's power 1, you get a positive 1. Once you reach 1, you are done. There is your answer. There is your prime factored form. Okay. This is so in other words, 48 equals to 2 power 4 times 3. This is the prime factorization. Okay, this is a crash course on prime factorization. I'll leave you to practice on your own. LCM, go for highest power. HCF, go for lowest power. I'll leave it at that. Okay, now that we know 16 is 2 power 4, we can substitute in. So first step is to substitute prime factorize first. Bracket power 3 over 4. So what happens here is you should realize that there's a invisible multiplication going on here. Okay, I'll just write the times like that. So when you have a times b to the power of m, you can sort of distribute the power. So a power m times b power m. Okay. So in that case, you can sort of distribute the 3 over 4 into each of those powers. So what do we end up with? 2 to the power of 4, bracket to the power of 3/4, times x power 8, bracket to the power of 3/4. Perhaps it's better if I just put this invisible pair of brackets around the a and the b, right? Yeah, that would look a bit nicer. Okay, easier to follow. Okay, then now when you see power raised to a power, what do you do? multiply the power exactly. So 4 times 3 over 4, you're left with 4 cancels away, just a 3, times x power 8 over 4. Right, 8 times 3 over 4. Maybe I write it as like 8 times 3 over 4. This is scratch work. Not part of the official working. The official working is here. 8 times 3 over 4, you can type in a calculator, or you could just do some quick mental sums. 8 and 4 cancel away, 1, 2. 2 times 3 is 6 over 1. So it's just x power 6. And simplify, you get 2 cubed is 8 times x power 6. That's your answer. Next one, 81 to the power of p over 3 power q equals to 27 to the power of r. Such big numbers. Okay, 3 is quite small and friendly and prime and odd. I like to leave the 3 alone. I wonder if 81 and 27 could become smaller, if it could be related to 3. Ah, yes. I remember the advice from the previous part. When I see big numbers, I prime factorize. So I proceed to do that. Let's see. 81 is 9 times 9. That's this is if I'm using mental sums. Right. Oh, what a coincidence. It's nice. 2 same numbers. Okay, and 9 is 3 times 3, 3 squared. Okay, that's interesting. So of course the same for the other 9. Same base, different power, multiply. What do you do to the power? Add the power. Of course, this is just 3 power 4. Okay, that's interesting. How about the 27, the rather big number, the base? Oh yeah, it's 3 power 3. Take note, 3 plus 3 equals to 6. 3 times 3 equals to 9. 3 to the power of 3 is 3 times 3 times 3, which is 27. As compared to 2 plus 2, it's a 4. 2 times 2, it's a 4. 2 power 2, it's a 4. This is purely coincidental. How do you spell? Incidence. Coincidence, This typically addition, multiplication, and raising to a power, exponentiation, they will give you very different answers. Okay, maybe I should write it a bit higher. Yeah, it's purely a coincidence that 2 plus 2, 2 times 2, and 2 power 2, they all give you 4. Okay, remember the Spider-Man meme. Okay, good. Yeah, 27 equals to 3 power 3. 3 power 3. Good. So now that we know the base is equals to those guys here and there, just substitute in. 81 is 3 power 4 to the power of p, so bracket power p, over 3 power q, just copy. 27, I replace it with 3 power 3, bracket power r. Let me color code it. You cannot use a highlighter during exam, but I'll just highlight it to make it clearer. Okay, good. There will always be an invisible pair of brackets before you raise it to a power. Okay, good. So I'm just filling it in now. Good. So what you realize is that there's power to a power. What do you do now? 3 power 4 to the power of p. It's just multiplication, so 4p, right? Over 3q. Sorry, the equal sign should be in the middle. Equal sign, and 3 to the power of 3r. That's just 3 power 3 times r, just 3r. Okay, then you realize here and there, same base, different power. A power m over a power n equals to a power m minus n, right? But make sure you have an invisible pair of brackets around the n, or in case the question becomes something like 2 power, they try to trick you and they say something like 2 power 3 over 2 power 5 minus x with a minus sign. In this case, if you wrote down 2 to the power of 3 minus 5 minus x without the brackets, you will be wrong. You need the extra pair of brackets here. I'll use pink color to make it the same. Okay, you need an extra pair of brackets here because the negative must be multiplied in, so that the 5 minus x becomes minus 5 plus x. Negative times negative gives you positive. Okay, so always remember the invisible pair of brackets after a minus sign. The notation usually doesn't include the brackets because they want to make things simpler, and mathematicians are usually very lazy in their math notation. So we keep things simple, avoid brackets, when actually there is an invisible pair of brackets there. So anyways, this 3 power 4p over 3 power q is just going to become 3 power 4p minus q, bracket, but of course in this special case, when it's just a single term q, multiplying the negative, you don't need the brackets, negative times into a single term q is just negative q, equals 3 power 3r. Now we did this question in class before. Same base, 3 different power. What do you do now? Equate the power straight away. That's it. 4p minus q equals to 3r. Now find an expression for q in terms of P and R. That is telling you make Q the subject. Okay, English comprehension. It is equivalent to saying make Q the subject. So here, is this our answer? No. Here, they already wrote for you Q equals, so you have to make Q the subject. How do you do that? Let's go. So 4P minus Q equals to 3R, 4P equals to 3R plus Q. So if I want Q as a subject, I can just bring the positive 3R over. I get 4P minus 3R. Answer. Erase this. Oops. Okay, done. What's the next question? Let's see. 15 is done. I want question 17. Let's see. Factorize completely the following. So what you want to do is to look at the first two, and then you realize you are stuck because there is no common factor, and that's when you realize you should probably be doing some shuffling. Yeah, but maybe you could be looking at the second pair as it was given, and you realize, oh, there's a common factor of -3, so you factor out as -3 bracket x minus, sorry, it should be a plus here, and wy. But even though the last two terms can be factorized, the first two terms cannot, right? The moment you hit this roadblock where the first two terms cannot, please shuffle the terms. What I recommend is to swap the second and the third term around. Okay? Let's see what happens then. 9wx, the plus y and minus 3x swaps around. And then you minus 3wy. Okay? Let's see now what happens. The first two terms, any common factors. First, you deal with the numbers, coefficients. 9 and -3. Any common factor? Yes, there's a common factor of 3. Bracket. 9 divided by 3, you get a 3. Then, pause there. Maybe we can go a bit faster. Let's also look at the letters. Wx and x. Any common factor? Yes, there's a common factor of x. So we factor out x as well. X. Yeah, so 9wx, take out 3x, you're left with 3w. Okay, very good. Next one, minus 3x, take out 3x. What are you left with? Minus, that's an invisible 1. Okay, there's an invisible times 1 here. So if you factor out negative 3x, 3 and x gone, you're left with -1. Good, so carrying on, next one, plus y, there's also another invisible times 1 here. Any common factor? Look, yes, you can see straight away there's a plus y. Then you're left with 1 minus 3w. Okay. Oh, you realize they're not exactly the same, but almost, right? The thing in the bracket must always be the same, this one. But they are very, very close. What's so different about them? This is plus 1, that's a minus 1. This is minus 3, that's a plus 3. Oh, they're off by a minus sign. So one further step you could take is to factor out a negative sign here. So copy. I'm not doing anything here to the first part. Please copy down exactly. Then this part here, plus, I change it to a minus. I factor out an extra minus sign. So instead of plus 1, it becomes minus 1. Instead of minus 3y, it becomes plus 3w. Sorry, instead of minus 3w, change to plus 3w. But I want to make it look exactly the same as this other guy, so I'll just purposely swap them around. Plus 3w on the left, minus 1 on the right. Transfer it back in. Whenever there's a plus sign in front of a number, you don't need to write that down. And then you realize, oh, they are exactly the same in the bracket. So that means you have another factor, 3w minus 1, factor it out. What are you left with? 3x minus y. Okay. I use a different color. Light blue, factor out. 3x multiply, minus y multiply, bring it over. Done. Okay. Stuck. Swap. When you are stuck with two of the terms you want to factorize, swap the second and third term. After the swap, past tense, swapped, exclamation mark. Swapped, then you proceed to factorize. You realize it's a lot easier. Next one, this one, oh, a little bit challenging because there is an extra coefficient in front. So your first step, 5x power 4 minus 80 times y power 4, you want to factorize completely, is to factor out the 5. Get x power 4 minus 80 over 5, let's see, that's a 16, right? Y power 4. Then how? Whenever you see a minus, and you see 4s, I hope your mental sums is ringing. You realize that it's related to 2, right? Can divide by 2. 2 times 2 is 4. So in other words, we could always rewrite this x power 4 as x squared minus 16y power 4. Y power 4 can be rewritten as y squared, but 16, can it be rewritten as something square? Yes, it is 4 squared. Well, square times y squared, is there a nicer way to write it? Sorry, maybe more like 4 squared times y squared squared. Is there a nicer way to write it? Yes, we can factor out essentially this power 2. So we are left with 4y squared bracket square. Right? It's because of ab power m equals to a power m b power m, invisible pair of brackets, where a is in this case, let's see, a is 4, b is y squared, okay, and m is 2. Y squared is a power 4. Very interesting factorization, and don't forget the brackets here and a 5 in front. Copy down the 5, copy down the bracket in red. This a square minus b square form. You realize you can factorize as a plus b, a minus b, right? So we're gonna do that. Close the bracket in red. Oh, but at this stage, what a coincidence, because this is just all multiplication here. We don't need the red pair of brackets anymore. It is equivalent, because math notation is lazy. Even though there's an invisible, it's not wrong to put a red color pair of brackets. I'm just going to make it simpler by removing it. Then, oh yes, wow, so much work done. I used the difference of squares formula, a squared minus b squared equal to a plus b times a minus b one time. I'm done. I can move on. Yay, right? Wrong. Here, there's an x squared minus 4y squared. Can we go further? Yes, we can. The 4y squared can be rewritten as 2y bracket square. Okay, why? Let's slow it down a bit, explain a bit more. 4 is the same as 2 square, so we replace it, you get 2 square y square. Then you realize it's similar to this form where a is 2, b is y, and m is 2. So you can go from the right to the left, and you end up with bracket 2y bracket square. Right? Yeah, good. Okay, maybe it's nicer if I just write it all in one line. Something like this, yeah. Save some space. Okay, so we end up with bracket 2y bracket square. Okay, then we can just substitute in. So over here, we'll just save some space by shrinking it down. Copy and paste this part here, but the 4y square gets replaced with, what was it? Bracket 2y square, right? Minus, okay, I have to show it over here. I have to replace it with 2y bracket square. Close the bracket. Oh, you realize again, a squared minus b squared. Previously it was a squared minus b squared. So in that case, you can factorize it again. You end up with, for this part here, a, think carefully, it's a x, it's not x squared, plus a b, in this case it's a 2y, bracket, a, in this case x, b, in this case 2y, but with a minus between. And that's it for the factorization for this part here. The left part, the part that was not modified, just copy and paste it down. And then you're done. This is the final answer. I think I gave something similar where it was like x power 16 minus 1, right? Go look at your homework questions. Okay, x power 16 minus 1. I think I explained this during class before. You can always break it down into x power 8 square minus 1 square. 1 is very special. It can always be written as 1 square. You get x power 8 plus 1, x power 8 minus 1. The 8 can be further broken down into x power 4 bracket square, and then so on and so forth. You keep on factorizing. Yeah. Next question. Let's see, what did I want to talk about? This was question 17. Okay, time to move on to paper 2. Let me see. Paper 2. Okay, paper 2, let's take a look. So we want to look at question 1 and question 8. Okay, so a equals to 3 minus b over b plus 4 plus 2. Find a when b equals to negative 6. Easy, just substitute. So a equals 3 minus b over b plus 4 plus 2. The blank spaces replaced with negative 6. Negative 6. You can just use a calculator. You don't even need to think about it. Negative and negative gives you positive. I have a calculator. I don't need to think about it, right? That's bad teaching, but exam strategy wise, this is the best method. Negative 5 over 2. Shift SD. Press equal sign. Shift SD. Okay, and then I get negative 2 half. Right, good. So you write that down. Negative 2 half. Next, rearrange the formula to make b the subject. Okay, this one requires a bit more work. A equals 3 minus b over b plus 4 plus 2. Let's take a look. So first thing, you want to isolate the b, correct? So where do you see the b? Here and there. Which is a part of what? Part of the numerator, part of denominator of a fraction. There are two separate terms here. A fraction on the left, a 2 on the right. b is a part of the fraction, which is a single term. So well, we can't really modify a fraction except for cross multiply, but you should know that when you want to cross multiply, cross, that only works if it is a single fraction on its own, right? It makes your life easier. So what we want to do now is to isolate the fraction so that we can do cross multiplication. And in order to do so, the plus 2 must go away. So where can it go? Other side, a minus 2. Does that make sense so far? Hopefully. You want the b to be the subject, but b happens to be stuck in the fraction, so you must leave the fraction alone. Leaving the fraction alone means that the plus 2 must go over. Okay, and right, a minus 2 actually will be equivalent to a minus 2 over 1. So now you have fraction equals to fraction. Is it easy now? Can you cross multiply? Yes. This one goes there, that one goes there. You're left with a minus 2 bracket multiplied by b plus 4 equals to 3 minus b multiplied bracket 1. But wait, times 1 might as well not write it. You could have just write down 3 minus b, right? Times 1 doesn't do anything. A minus 2 times b plus 4, you can distribute a goes into the first and second, so ab plus 4a. Next one, negative 2 goes into the first and the second, so negative 2b, negative 8. Good. Now ab, so remember the goal was to make what the subject? Make b the subject. So that means we have to identify where's our b's again. Here and here. So and there, sorry. Missed that out. So what you need to do is to make sure that those terms, those b terms, all appear on the left side, or the other non-b terms go to the right side. So here's how we can do it. Those that are underlined, leave it alone. Minus 2b, leave it alone. It's because it's already on the left side, so you can leave it alone. But this minus b is not on the left side yet. So bring it over. Bring it over. Minus b becomes a plus b. Becomes a plus b. Right? Equals to, copy down 3. 3 doesn't change, right? So just copy it down. But what happens? What happens is that this 4a, this minus 8, I don't want it there. I don't want it on the left side. I want b on the left side only. So you just bring them over. Bring them over. And then as a result, what do you get? You end up with plus 4a, bring over, get a minus 4a. Minus 8, bring over, get a plus 8. Very good. Okay, now we can simplify the right hand side a little bit. 3 plus 8, what do you get? 11 minus 4a, just copy down. Minus 4a, just copy down. But for this left hand side, anything we can simplify first before continuing on? Yes, minus 2b plus b. There's an invisible plus 1 here, so minus 2 plus 1 is minus b. ab remains at the front. You want to make b the subject, so usually at this stage, you would want to factor out the b. So factor out the b, what do you get? A minus 1. Okay, 11 minus 4a, nothing happens. Nothing happens. So now you want to make b the subject. Hopefully you can see that it's b multiplied by something. So if you make b the subject, times a minus 1, bring over becomes divide by a minus 1. The 11 minus 4a remains at the top, and there you go. You get your answer. Okay, good. Next one, part B. Solve these simultaneous equations. You must show your working.